Alright, we're going to go ahead through on page 106, problem R5. This is the computer time problem. Now, this one is one that has been considered rather challenging in the past, and we'll go ahead and look at it right now. If a computer program has a loop in it, the length of time it takes the computer to run the program varies linearly with the number of times it must go through the loop. Suppose the computer takes 8 seconds to run a given program when it goes through the loop 100 times, and 62 seconds when it goes through 1,000 times. Now, essentially, when it goes through a loop for the computer program, it's cycling through the same set of code over and over and over again, which takes time for the computer to process. Now, we have two things that are involved here. First of all, the amount of time it takes to run the program. So we'll call T equals the time to run, and that's in seconds. And then we also have the number of loops. Now, the time it takes depends on how many loops it goes through. This is our dependent variable. And n is our independent variable. Now, it's our independent because the more loops will end up making more time that the program takes. Now, what we have here, 8 seconds when it goes through the loop 100 times and 62 seconds when it goes through 1,000 times, are 2 points. So, our independent, our number of loops for the first one would be 100, gives us 8 seconds. And then our other point is 1,000 loops, gives us a program of 62 seconds. We want to write the particular equation expressing seconds in terms of loops. So, we can go ahead and find the slope here. So 62 minus 8, we have 54, divided by 1,000 minus 100, 900. And we'll reduce this fraction, divide it by 9 to get 6 over 100, or give us 3 over 50. 54 is talking about seconds, so we have 3 seconds per 50 loops. Now, we can go ahead and use one of these points for point-slope form. Let's go ahead and do the dependent first. That's t minus 8 seconds equals 3/50ths and minus 100 loops. This is our independent variable, and this is the dependent variable, which depends on this variable. We can go ahead. This is perfectly fine particular equation. I know a lot of us like it better when it's set up into slope-intercept form. So I'm going to do that right now. And then we can go ahead and add the 8. So we have 3/50ths n plus 2. No, sorry, I just lost the problem. My iPad. Here we go. Predict the length of time needed to loop 30 times and for 10,000 times. So we have n being 30 and n being 10,000. So P when n is 30, T is 3/50ths times 30 plus 2. So that's 90/50ths, or 9/5 plus 2, which is 10/5. T equals 19/5 seconds. Then we have the 10,000 loops, so 3/50ths times 10,000 plus 2. Let's see here. This is 1,000 divided by 5. It's 200 times 3 is 600, plus 2 is 602 seconds. So if we go through 10,000 loops, it'll give us 602 seconds, so a little over 10 minutes, and then we'll have 19/5 seconds, so a little less than 4 seconds if we only had 30 loops to go through. Now that's part B. Then we have over here C. Suppose the computer takes 23 seconds to run the program. How many times did the computer go through the loop? Well, we see that the 23 seconds is T, your time. So you go ahead and plug that in. 23 our time, 3/50ths, and our number of loops plus 2. I'm going to start solving this right away. 21, 3/50ths n. Divide by 3 gives us 7, multiply by 50 gives us 350 is our number of loops. Now we have those 3 pieces. And then we can go ahead and look at D. How long does it take the computer to run the test of the program excluding the loop? Well, that would mean we have 0 loops. Well, if you go ahead and look, when you have 0 loops, and the number of loops is 0, it still would take 2 seconds. So, the program itself, without the loops, would be 2 seconds. Now, the t-intercept tells you that. Let's see here on E, it says how long does it take the computer to go through the loop once? Well, we have our single loop being 3/50ths of a second. So that's how long it takes to go through a single loop. Now, I think part E is kind of ambiguous because it's kind of hard to be able to tell if it wants you to just go through one loop or if it, including the entire program. I know you guys can't see that very well. Here we go. Now, but I think it just wants to know the rate of change, so that would be 3/5 of a second for every loop, and that would be the slope telling you that. From this position, I think you guys are well positioned to go and graph that function.